Hi everybody, Christopher Collison here as we continue to talk about the opening lecture on Chemistry 670. This is about scientific communication, and so we're left with the idea that no job is done until the paperwork is complete. So what does that mean in terms of scientific dissemination? Let's take a look. Well, this is what I'm talking about. The work of a scientist must be demonstrated and disseminated, with dissemination being the key topic here. So how do we disseminate our work? Well, we want to put our work into peer-reviewed journals. We're interested in telling the truth as a scientist, and we want for other people to critique us and for questioning what we're about to tell them. So we need to have these peer review systems set up so that we can guarantee or we can buy into the material that's being presented in these journals. We're also taking results that are based on logical causal relationships in science. That's just the way that science is. So, in fact, there are many ways that our paperwork can be done, many ways that dissemination and peer review can be done. So I'm going to go through a few of these. So first of all, we can talk about a paper, a journal article. These papers reach thousands of people, and so the reach is large. The details are significant in the paper, so everything goes into that paper. The methods section tells us, for example, how the experiment is run in great detail. The results on the conclusions are put forward in the written form. What other forms of paperwork are there? There may be a poster, so often we can present a poster at a conference, and this is right at the other end of the spectrum compared to a paper. Our reach here is usually one or two people, but we end up having some good discussions about the science that we're studying, that we're working on, and often this is how collaborations evolve. We may also give a talk or a seminar at a conference, and this is somewhere in between the paper and the poster. Our reach usually here is somewhere between 40 and 100 people. Lots of people get to see that work fairly intimately through the description by the presenter. And often the time that the presentation takes is somewhere between 15 minutes and 60 minutes, and usually that's a lot shorter than the amount of time required to thoroughly read a paper. So this is a good way of getting a feel for what the science is all about in a particular paper. Go see the talk or the seminar based on that particular piece of work. Lastly, we're going to have a patent. We won't talk so much about patents, but patents are a way in which we can take some intellectual property, some ideas, and write them down and claim them and own them so that effectively we can sell those ideas commercially in the future. So that concludes the section on research and the MS program in chemistry. Regarding how we start to understand the science that we're going to be undertaking, and how we can present that, how we can put that out there into the wide world. Another thing that I want to talk about very briefly is how we read papers. I've mentioned that we need to look at our literature, we need to look at the papers that are out there to understand the system that we are studying. So how do we read a paper? I think the best way to engage with somebody else's work is by writing a review of that work. And I'm going to ask you to write a review paper in the coming weeks for a paper associated with the advisor that you choose for your research. And here's how I suggest we write a review. And I do this as well if there's a paper that I particularly appreciate or one that I want to present to my own research group. I read the abstract once, and on a second pass, I make a written note of the problem statement, the technique used, the main conclusion, and the value of the work. This sets the scene. This sets the context for the rest of the paper. It means that everything now is going to be slightly easier to read because I know what the publication is all about. I know what the paper is about. What else do I do? For each figure, I will go through and look at the axis titles. I will read the caption, and I can summarize what I see in the figure. I can also describe the trend in the data that I'm seeing. I write that down, and that gives me again another way of understanding what the paper is all about before I even dive into all the text. When I'm writing a review, I then look paragraph by paragraph through the entire paper. And for each of these paragraphs, I try to note down what the key subject or topic is of that paragraph. And I try to summarize the paragraph in a single phrase or sentence. I actually do this as well when I'm reviewing my own papers and my own proposals. This helps me recognize the skeleton of the work that I'm looking at, maybe the skeleton of the work that I'm writing. Sometimes the conclusion of the paragraph might be different to the topic of the paragraph. If that conclusion is particularly important, I may want to write that down too. And it also gives me an idea as to what's coming in the subsequent paragraphs. So this is how I engage with a scientific publication, a scientific paper, and how I would write a review so that I really know intimately what is going on within that piece of work. So, as part of your scientific development, you're going to read a ton of papers, a lot of papers. And by doing that, you're also going to appreciate the quality of the work and the quality of the communication. So I want you to think about this for a second. We might have some really good research, but if we can't communicate it well, it's going to have a lower impact in the field. And by the way, our success as a scientist comes down to the impact that we make. You remember those H-index numbers that I talked about in an earlier presentation? That describes your impact as a scientist. So good research, but bad communication means you'll have a lower impact. If you do bad quality research, but you're an excellent communicator, of course, you're still going to have a lower impact because the research itself doesn't have such an impact. So ideally what we're looking for here is good quality research, and that means intellectual merit, broader impact, and novelty, but we also need to be able to communicate well. And that's the best way in which we can improve our H-index and have a higher impact on the world around us. So a key feature of CHEM 670, by the way, is quality in writing. And so I put it to you that you already know what good quality writing is. There's an exercise that I'll ask you to do in class where I'll ask you to look at two different summary statements for some scientific work, and I'll ask you to let me know which one you think is better. And what we'll hopefully recognize is that there is a way that we can discern good quality in writing. So we'll come to that later. How can we learn to communicate well? Sometimes people say, I'm not the best writer. I haven't been taught to write well, but I'm a scientist. I'm an engineering major. I don't need to know how to write. Well, hopefully by now I've convinced you to recognize that writing is really important if we want to have an impact. So I hope you get your head around the idea that we can all improve as writers. The second pushback I get from people is, I don't know what good writing is. So I put it to you that I think you do know what good quality is. So if you ever have an opportunity to look at this particular link, you'll have a look at some home creativity and how certain things don't always work out the way that you want them to work out. We kind of know what quality is. So have a laugh with this particular link. And scientific writing, so we'll do this exercise in class where you can look at two different summaries and you'll tell me which one you think is better. We're going to review each summary, which one is higher quality. You'll tell me. We'll do that exercise in class. So at this point, we're going to take another break and we'll come back in a second to talking about project outlines. and we'll start to talk about how you move forward with your research. We'll also start to talk about the first elements of improved writing, and we'll work on those as we move through the class. So thank you for listening.